The last lesson in the hardware topic is secondary storage devices. As usual, quick starter to begin with. Which of these will increase the speed of a CPU? Increasing the clock speed, increasing the secondary storage, increasing the number of cores, increasing the primary storage, increasing the cache memory, or increasing the power? Okay, let's have a look at the answers. It's increasing the clock speed, increasing the number of cores, and increasing the cache memory. If you said increasing the primary storage, you're sort of right. That will increase the speed of the computer overall, but it won't affect the speed of the CPU. Always read the question carefully. Right, so this lesson is about secondary storage. So in this lesson, we're going to learn about some different secondary storage devices that can be used with a computing device and the advantages and disadvantages of each. But first, let's take apart a computer and look at how all the components we've looked at so far connect. For this, we'll need a table and a computer. Let's go. Okay, let's take the cover off this computer. Inside, you can see a motherboard. That's the big circuit board underneath everything else. And all the other devices connect to that motherboard. First one I'm going to remove is this one here. By pulling these two clips out, it lifts up and I can remove this. This is the RAM. This is the primary storage. This is the volatile, fast storage where instructions that are currently in use reside. You can see under here there is a second RAM slot. That's for if you choose to add more RAM to your computer. The next device I'm going to remove is this one. I'm going to pull the cable out, pull this clip in, and this pushes forward. This is a DVD drive. This is an old computer and still has a DVD drive. Most modern ones don't have these anymore. We'll talk more about the DVD drive later in the video. The next component is under this caddy. I'm going to lift this up and out it comes. It's attached to this metal part which keeps it in the case, but this is the magnetic hard drive. This is the secondary storage. This is where the operating system, the files, the programs, the apps all reside permanently. The last component is underneath this great big hunk of metal called a heatsink. This hunk of metal exists to keep this component cool. This fan blows air through this metal component which draws heat away from it. I'm not going to take this one out right now, but underneath we have something that looks like this. This is the CPU. Keeping this component cool is vital because as the clock speed increases, the temperature increases. Keeping the CPU cool means we can get more clock speed out of it. In our computer, we found a magnetic hard disk, which is used as this computer's main secondary storage. This is still one of the most common secondary storage devices, but it's on its way to becoming obsolete. Let's take a closer look at the magnetic hard disk. Inside is a spinning platter of disks and a read head that slides across them, detecting the polarity of microscopic magnetic particles. To fit the 1 to 3 terabytes found in a typical magnetic hard disk on here, the read head moves with extreme precision very close to the spinning disk. Because of this, the device is quite fragile and can be damaged with a knock. The need for the spinning disk and the physical movement of the head means magnetic disks use a lot of power and are relatively slow to read. I mentioned that magnetic disks are becoming obsolete. This is because of solid-state disks. These devices use an array of microscopic components that can hold a charge to store their data, essentially making them behave as switches. There are no moving parts. Because of this, they are very robust. That means they are very difficult to damage. They consume little power and they can be made physically very small. SSDs are better than magnetic disks in every way, but right now they are still more expensive, so magnetic disks are still used. The gap in price is shrinking, however. Eventually they will be a similar price and magnetic hard disks will just disappear. The third type of secondary storage device is optical storage. Optical devices, such as CDs, DVDs and Blu-rays, are discs covered in a reflective surface. The data is stored by making tiny portions of the disc non-reflective. A laser is shone onto the disc, and if it reflects back, then a 1 is stored. If it doesn't, it's a 0. Optical discs are slow and a little fragile, but they are still very portable and incredibly cheap to produce. Console games are still distributed this way because of their cost and portability. These are the notes you need to make for this lesson. Magnetic storage uses magnetic particles on a spinning disc to store data. They are cheap, but they're fragile. They are physically large, they're power hungry, and they're relatively slow. Solid state uses microscopic switches to store data. They are still expensive, but they are robust, they're physically small, they can be very power efficient, and they're very fast. Optical devices use a reflective surface to store data. They are very cheap, they're quite robust, but they're very portable and very slow. Question for you. In these 3 scenarios, which type of secondary storage device is most suited? Scenario A. A small action camera designed to be attached to cycle helmets and snowboards is being designed. What type of storage should the video record onto? Scenario B. A demo of a game is going to be bundled with an industry magazine. What type of device is it best to bundle it on? And Scenario C. A security camera server which receives and stores video from all the cameras in a building needs storage for those videos. What type of device should be used for this? All the answers. The action camera would need a solid state storage. A magnetic drive would be too fragile, too large, and would drain the battery too quickly. The demo game could be distributed on an optical disc because it's cheap to produce and it could fit inside the magazine. And the camera server would probably use magnetic drives. They could use SSDs, but magnetic drives are considerably cheaper, and because the server doesn't need to move, the portability and the fragility isn't an issue. Your assessed task is to create a single page sheet which explains the 3 secondary storage devices we've looked at. For each device, there must be a picture, information on how it stores the data, and information on its advantages and disadvantages. You can do this pen and paper or on the computer. Either way, your sheet needs uploading to the VLE.